Wow, can you believe it? It's been 19 years of Spring and already 11 years of Spring data. We've gone from Java 6 to 8 to 17, with 19 already being out. That's quite a lot of releases that come up these days. Still, you can recognize the patterns that you're used to when you're working with the Spring application. And for the Spring Data 3.0 release, we've been following exactly that guidance and not reinventing the wheel, but sticking to the patterns that are well known already and just making tiny modifications and conscious decisions on the API, which will serve us for the next couple of years. My name is Chris, and on behalf of the Spring Data team, it's my pleasure to show you around what we've been coming up for you in the Spring Data 3.0 release. Obviously, we've been following Spring Framework 6 guidelines and upgraded the Java baseline to Java 17. And we also switched to Jakarta EE9. All of this comes with certain implications that we're going to look at right now. So first of all, one thing that you may notice is that Spring Framework 6 deprecated the listenable future interface in favor of the completable future ones. Though the change is rather simple to mitigate, you'd have to go from using the add callback method to the when completion stage of the completable future. It's highly likely that you won't even face the changes there that we did, unless you're one of the users of Spring Data for Apache Cassandra who's using the async Cassandra template. Because following the deprecation, we removed the listenable future from all of our public API. So if you've been using the async Cassandra operations, then you'd have to go through the changes and switch to the completable future. If you don't want to touch all of your code right now, we still got you covered and move the existing API that contained the listenable future return type into a legacy package. So if you want to upgrade but still don't want to change your entire code but just change the imports, then please go ahead and use the legacy package that we have prepared for you. Speaking of deprecations, those of you who had a close look at deprecation warnings within the build might have recognized that the support for RxJava 1 as well as RxJava 2 repository interface definitions has been deprecated for quite a while in the 2.7 or 2.x release line. Going forward, 3.x removed the support for RxJava 1 as well as RxJava 2 entirely, and the options there are either to switch to RxJava 3, which can be done very easily because all the types are there, just in another package, or to go for a project reactor and switch to another reactive library, more or less. Another change that we know is going to affect quite a few people out there is the switch to the Jakarta EE9 baseline, more or less, because in this case, you have to switch from the JavaX persistence namespace to the Jakarta namespace, apparently. The good thing about this is it's a rather trivial change that you can easily do by just using a simple bash script and replace the JavaX namespace with the persistence with the Jakarta one. This example works for all the data related bits. If you prefer a more automated way, you can go for Open Rewrite, which has a dedicated recipe that migrates your application from JavaX to Jakarta EE, also taking care of all the validation stuff that might be in there. Or if you happen to have a Spring Boot 2.7 application that you want to entirely migrate to Boot 3, then you can try out the experimental Spring Boot Migrator project, which will use the Open Rewrite recipe recipes and apply those for you, and also do some other stuff to migrate your application to the next generation. We are absolutely aware that not everyone will be able to follow these changes right away. It takes some time to alter your projects, to migrate your projects, maybe first to Java 17 and then following along to Spring Boot 3. That's why we extended the support period for the Spring Data 2.x line quite a bit. So it will last till November 2023. And if you want to learn more about the individual timelines for each and every project, just go to the Spring.io website, select your project, and head over to the support tab. There you can get all the information that you're looking for. I've not only good, but also some sad news to share. Unfortunately, the Spring Data for Apache Geode project had to leave the release train on the late announcement, because in October 2022, the Apache Geode project failed to secure enough seats on the steering committee and was discontinued. So we had to make the hard decision there and remove Spring Data for Apache Geode from the release train. At this point, I want to give a huge shout out to the entire Apache Geode community, who's been very supportive, as well as the team taking care of the Spring Data for Apache Geode module. Thank you very much. But now let's move on to more fun stuff and the new things that we've come up with for you in the Spring Data 3.0 release. First of all, there's a change that you might notice in the repository composition. So throughout the life cycle of the 2.x generation, we received several requests to rethink or maybe even redesign the hierarchy of the repository interfaces. And with the 3.0 release, we were able to do this. And I'm going to show you what this exactly means for you if you're working with Spring Data. So if you've seen last year's talk on Spring Data, you might be familiar with that the repository allows you to define the aspects of what you want to expose to the outer world. So you have a control about which methods you want to expose. Because by default, the repository interface itself is just a marker interface that doesn't have any methods. So you could go ahead and define a find all method in there that matches one of the CRUD operation, one of the methods that is within the CRUD repository. So you can find all the domain types in your data store, and then this would be available to you, but just only this method. And you could go on and define in that way a read-only repository if you want that doesn't have any of those methods. But you could also go on, if you say you want to have some predefined functionality like paging and sorting, you could go on and use the paging and sorting repository, which comes with an already predefined set of methods that allow you to go through your data set, not as an entire set that you need to load into memory, but page by page. So you can just get slices out there. As you see here, you can sort and you can page through your data set. But, and that was one of the points that we wanted to address with the 3.0 release, is you'd also get the delete and the CRUD methods, basically the exists and save methods that you potentially wouldn't want to expose just because the paging and sorting repository extends the CRUD repository, which in turn defines the save and delete methods. So that was one pain point for some users, because you couldn't use the paging and sorting repository standalone. The other thing is the CRUD repository already defined a find all method, as I mentioned before. But the thing there is, let me just uncomment this for short. I could use the find all method that I defined up here, and it would give me a list of all entities within my data store. The CRUD repository defines this method, but in a different way, because it uses an iterable instead of a list. So I could either use with the live with the iterable, cast it, or override the method declaration up here again to just get a list out of my repository. And we tried to address all of those points in Spring Data 3.0. And if we now switch over to an application that uses the 3.0 bits, then the repository definition would look pretty much the same, but with one big difference. You will see an error on the save method if you've been using that one. Just because the paging and sorting repository no longer extends the CRUD repositories. So if you happen to use the save operations, then you'd have to add the additional interface definition for the CRUD repository in order to be able to use the save method right here. This is a breaking change, we know. Still see it as an opportunity to revisit your repository interface implementations if they really need to expose, let's say, a find or a delete method to the outer world, or if they are just can serve their job by just having the listing functionality or the paging. Right. And now let's have a look at the find all method, what we were able to do there. Still, the CRUD repository predefines the find all method, as we've seen before. And it still uses an iterable. So you would have to maybe override it again here. But we've added a couple of predefined repository interfaces to the code base, like the list CRUD repository, which overrides or predefines already defined all methods with a list. And we've done this for the query DSL predicate executor as well as other repository types, so that you don't have to redeclare the finder methods, the returning a list yourself. We hope you find this feature useful. That's been it for the composable repositories. So let's move on to another major theme that not only affected us as a Spring Data team, but the entire Spring ecosystem. So from framework to security to all the other projects, batch and stuff. And if you look at an application like this, so this is a very trivial Spring Boot application using a command line runner. And since we're talking about Spring Data here, it just uses 2 Spring Data repositories and then does a bunch of CRUD operations and list operations that you typically would find, like list all the authors, or you apply an entity graph, or use a derived query or a native query, well, what have you, or even use a projection within the repository interface, because you can use a simple interface definition that matches the property names with the getter, and that one would be backed with the result set or even the entity type to limit what you expose to the outer world, basically, more or less. So you can define a subset of the attributes you want to expose with a certain method, and all of this, of course, happens by not magic, but just a bit of proxying, Java proxying, and then delegating to the according methods. Right, so this application doesn't look very much different from that one. Let me go back. It's the very same application, right? And that's what you would expect. But when it comes to the execution of this very application, there is a huge difference, actually. Because if you look at this output here, this is started as a native jar, and then on the other hand, the very same application started as a native image, and there is you can clearly see a difference in the startup time, because the executing the application as a jar includes all the ceremony from unpacking the jar and then loading the types, verifying that all the types are there, running stuff in the interpreter till it's warmed up. And so all of this takes time. So it's 1.5 seconds on my machine, whereas running this as a native executable eliminates basically all of the ceremony and other stuff. And already starts at peak performance in a couple of milliseconds. So that's really mind-blowing to me. It's great. If you look closely at this, then you will see that there is a difference, or also in the output of the application, because on the JVM we try to solve everything at runtime. So we inspect the path and look for Spring Data repositories, the repository interface, and then we detect those and know where we will have to instantiate a repository for this. And that one is clearly missing when starting the application as a native image, because we are leveraging the ahead of time compilation that is baked into Spring Framework 6 as well as Spring Boot 3. And in doing so, we are at build time already inspecting the application context. We already detect that there are several Spring Data repositories. We contribute the code that is necessary to spin up the repositories so that we don't have to do the scanning in the native image, and everything becomes way faster. You can also run the application in an AOT mode to have the very same experience as when it starts in the native image. And if you've been watching the keynote, then you might have already heard that building a native image isn't a free lunch, because you just can't. You have certain limitations, and you can't do all the stuff you used to do on the JVM. For instance, if you need reflection, then you need to tell the Graal VM native image compiler upfront which domain types you want to use reflection on. You need to tell it which fields with methods, which constructors. And as you can imagine, this is a huge burden for ORMs, because we naturally rely quite a bit on reflection data to just populate your domain types with the values retrieved from the data store. And in Spring Data, we contribute during the build time phase to the reflection configuration that is then handed over to the native image compiler by just taking your repository interface definition, looking at the domain type that's present there, and then trying to fan out and see what's reachable, which other domain types are related to the one. Like an author might have a relation to a book. So we need to also maybe set the book, so we add reflection metadata for the book and stuff like that. And we also contribute the proxy configuration that is required if you have defined a projection interface in your repository definition. Then we'll just see, wait, this is an interface. We need to do something about it, and we take care of it. If you're interested in what it takes, for example, to spin up your application with Hibernate, and what amount of reflection metadata that is required to have all this work, then you can head over to the metadata repository hosted at Oracle. It's an open source repository that contains a lot of those reflection configurations for third-party libraries that haven't baked them in natively right now. They might get there at some point in time, but right now they don't have. And so the framework itself, or Spring Data itself, won't contain any of those reflection hints, but just the hints that we need. And we contributed the required hints for all the Hibernate dialects, for example, to the open source repository so that it's usable for everyone. If you want to have a look at what this looks like, you can also find them in the build directory. So there will be a copy of it so that it works for you. If you happen to not work that much with the repository interface itself, but rather a template API like in MongoDB, then we won't be able to see your domain types based on the analysis that we're doing from the repository. But there is still a way you can tell us that you'd like to have work with those domain types and have reflection on it. And you can do so by registering a bean, which is called managed types there for the individual stores. You'll have Mongo managed types and Cassandra managed types and whatnot. And we'll pick these beans up at build time and also register reflection for you so that you don't have to do it yourself. This comes in especially handy if you're using a MongoDB DB refs that might be lazy and require proxying. So we'll have a look at those and then just add the proxy configuration so that it works for you. If you want to learn more, and I'm sure you do, then make sure to check out Sebastian's talk on Thursday. He'll tell you everything you need to know about Spring Boot 3 and the AOT story. The last but not least, major theme for the Spring Data 3.0 release was observability. So we made observability as the entire framework a first-class citizen, and it's baked in directly into the bits of Spring Data. Observability, of course, is a huge topic. So I'll be just scratching the surface here, and I tell you to go watch the talk on Wednesday, because there you can have the experts talking about observability and Micrometer. So what I'm going to do right now is I'm going to show you what it takes to use Micrometer traces and spans and all the context propagation within your application for, let's say, Apache Cassandra, MongoDB, and Redis, right? So I've been using Zipkin as a backend and prepared this, and with it, you can basically go and trace an incoming HTTP request right down into the actual database interaction and the query that is executed, the operation against a MongoDB database in this example. So you can see here, I drilled down into MongoDB. There is a GET request on employees, and this will result in an employee find operation on the database. And we even take it one step further. We use the open telemetry attribute name so that you can quickly relate the stuff, and then you can even see which host you're connected to, which database, which table is affected, and whatnot, and how long it takes. And all this will contribute to the entire span. And if you correlate this with logging and metrics, then you've got a pretty decent insight into your application. But again, make sure to watch out for the talk on Wednesday. For MongoDB, unfortunately, there's a drop of bitterness. The auto configuration didn't quite make it into Spring Boot 3.0 release. So currently, to use this feature, you'd have to, first of all, disable the auto configuration for the MongoDB metrics, unfortunately, and then plug in your own configuration. And you can do so very easily by just using the Mongo Client Settings Builder Customizer and add your Mongo Observer command listener. That's basically all you need to do. And then you can already go ahead and use the observation API to create the spans you need. Of course, we didn't stop there. There are some store specifics that I want to briefly touch and tell you about. So there is, for example, Spring Data JPA, for which we added an extension people have been asking for quite a while. And this is the ability to rewrite a query, because sometimes we reach the limits of what we can do with the derivation for, let's say, a count query or a sort query. Then the query rewriter is an option for you. It's basically a bean that you can register, or even a simple class that can be instantiated, and it will receive the query and the sorting, and then you can alter the query string as you like. It's also might also find usage for applying a tenant ID to your SQL statement. Right, so that's that. Spring Data JDBC is has been one of the fastest growing Spring Data modules throughout 2022, and a lot of things have happened there. So I want to highlight that there is now support for using spell within the query expressions, which allows you to integrate with, let's say, a security context that is provided somewhere, and you can use the Spring Security principle to just add the username to an existing query. So this is pretty nice and aligns the Spring Data JDBC module with the other modules that already support spell expressions within their queries. If you've been working with Spring Data before, you might have noticed that we're sending out application events for your domain type. So there's on-convert events or before-save events that notify other components within the application context about certain changes you're doing to the underlying data store. But we also support entity callbacks, and callbacks don't send out events to other listeners, but are meant to hook into the persistence lifecycle itself and then give you an opportunity to do something like, hey, I want to generate the ID for an entity myself. Just go use a before convert callback and set the ID as you like. And then it will be handed over to the conversion step with the ID already applied. During the work on the lifecycle events and the callbacks, we recognized also that there is a little downside in sending out lifecycle events. Because even though when no one is listening, it's causing some overhead because we need to create the object and there is a new flag to just disable lifecycle events if you know that there is no one listening or interested in the lifecycle events Spring Data is sending out. Right. One enhancement that you likely won't even recognize because it's built in under the hood is we are now batching JDBC statements within the driver. So previously we went if you have a relationship to many order and line items, then we'd persist the order and then we would go ahead and persist the line items one by one. Now we're doing it differently and as far as possible, batch up the operations for saves or deletes. Hopefully you won't recognize. Still, it's part of the driver's API, so it might differ a little bit depending on the database and the driver you're using. For Spring Data MongoDB, we've added the ability to use the aggregation framework to define MongoDB views, which comes in handy if you're already familiar with the MongoDB aggregation framework API. Also, we added the option to annotate, find and modify queries so that you don't have to directly interact with the template anymore, but you can use an annotated update statement to achieve the very same on the repository level already. Also using the derived finder query, so the select statement would be derived from the method name directly. And we caught up with really a lot of new aggregation framework commands because MongoDB is quite busy with adding new commands to their aggregation framework. So there's plenty of those new in the 3.x generation. We also made it simpler to use driver-specific native API with the aggregation framework that Spring Data provides by just using the aggregation.stage method. And then you can just go ahead and use driver API directly if you choose to. For data Redis, we support now JSON views, which let you give you more control about what is actually persisted when you store a domain type. So you can define a view and only a subset of all the information will be persisted within Redis. And that's been it for the 3.0 release. But we won't stop here. I got 2 more minutes or so I'm going to show you what's next and what the team is working on. We're working on single select statements that would allow you to go from a native join, which would in this case return 25 rows, to something that fans out the result set using row numbers and analytic functions so that you get basically the same result with just 5 rows returned. But that's ongoing work we are experimenting with, and we hope to finish this work this year, hopefully. So fingers crossed. Another thing we're investigating is better support for client-side encryption, in this case for MongoDB, so that you can already encrypt information on the client side before it's even sent over to the server, so that not even the server would know what this information is about. And of course, then retrieve it and decrypt the entire stuff again. But that's, again, future work, just a preview of what the team is working on. Hope you enjoyed the session. And with this, I want to thank you and hopefully see you next year.